All right, so that's another example. Now, if you remember also, I know I didn't go over it in this class, but you have probably seen in other math courses, writing a fraction in lowest terms, or writing it in reduced form, that is. Well, you can do that here with rational expressions. Namely, we say a rational expression is simplified if it has no common factors. The numerator and denominator, have no common factors except for 1 and -1. So the only common factors are of the numerator. The only common factors of the numerator and denominator are 1 and -1. Those are the only two. Those are always, 1 is a factor of any two polynomials. Same thing with -1. So you can't get around that. But if those are the only two, then it's simplified. But the idea is the same with fractions in lowest terms, right? You want to make sure the numerator and denominator have no common factors, except the trivial ones. Same thing here. Except the trivial ones here are 1 and -1. Okay, so we know what it means for a rational expression to be simplified. Okay. But how do we actually simplify it? Well, that's what I have in the next slide. That's what I have down here. You basically just have to, you can factor the numerator and denominator and just cancel any common factors. Mathematically, you're dividing by those common factors, the numerator and denominator. You have to divide. And what's really cool, because we did synthetic division, we can use the factor theorem to help us. You'll see that in the example today, that the factor theorem is actually very useful. And remember, I just wrote down what that says, as a reminder. If you have a polynomial, p of x, and a number a, x minus a is a factor of it if and only if, that is exactly when, p of a is 0. You'll see in the example we do shortly that, let's say x minus a was a factor of the denominator. Okay, let's say somehow we were able to factor it. But if the numerator was kind of tricky to factor, well, we can use the factor theorem and get around factoring, so to say. We could just check this. And if this is not 0, then this is not a factor. But if it is 0, we know it's a factor. But to actually factor it, we can use synthetic division. Okay, that's a mouthful, I know, so let's do some examples. We'll see that what I just said, we'll see it in action. Just get rid of this because I want to. Just getting rid of this ink that I wrote down from my other class. I think that's it. Yeah, okay, here we go. So let's simplify each rational expression here. Now, this is something I also pointed out. What the book does is they'll say something like x is not equal to -2 next to a rational expression. All that they're saying is we're working in the domain. That's all we're saying. So basically here we're assuming that x is not -2. That is, we're assuming we're in the domain of the rational expression. I just figured it'd be kind of silly for me to write that down. Only because if I ask you to find the domain, then, I'd be kind of giving it away. So, all right. Anyway, let's simplify this. Well, notice the denominator is factored already, right? You can't factor down x plus 2 any further. The numerator, let's look at. Well, again, it's just like finding the GCF, right? we have here, okay, the leading coefficient of this is 1, so we can't factor out anything from the coefficients. The x's, well, the smallest power of x is 2, smallest exponent, excuse me, so we can factor out x squared. Factoring out x squared, what happens? We get this, get x squared times this over x squared. That's equal to x squared times this, as you can see. Right? Again, you have to divide to see what's left over. When you divide, you're actually subtracting the exponents, so you'll get x to the first, which is x. Here, the x squares cancel, and you're left with this. So the numerator becomes this thing. And you can see from that, we can actually, we have a common factor of x plus 2. Well, what do? We're going to cancel it. And we get just x squared. That's what we get. And again, notice we're actually assuming x is not negative 2. So this whole equation, these equations would not make sense if x was negative 2, because you'd be dividing by 0. And the numerator would be 0 as well. Are there any questions on this? Again, I can't see the chat, so if you have a question, please ask through the hand raise feature. Okay, next. So here's a really fun one. I'm going to simplify this. Now, notice that it's not obvious if these two are factored already. So you could have a quadratic that you can't factor. That can happen. But since we have x squared plus bx plus c, let's try that method from earlier where we look for two numbers whose product is the coefficient of x, whose product is the constant term. The sum is the coefficient of x. In other words, for the numerator, we want two numbers whose product is negative 3 and whose sum is 2. Product's negative 3, the sum is 2. I mean, I have the answers already here, but even without it, you should be able to see that the solution's going to be, the two numbers are going to be 3 and negative 1. As you can see. Right there, product is minus 3, the sum is 2. Yahoo. Yippee. So from here, you get this. We get x squared plus 2x minus 3 is x plus 3 times x minus 1. Again, let me say it again. The two numbers we want, 3 and negative 1, they're two numbers whose product is minus 3, whose sum is 2. And those two numbers, are 3 and negative 1 because their product is negative 3, their sum is 2. 3 plus negative 1 is the same as 3 minus 1. And so we get x plus 3 times x minus 1. For the denominator, same idea. We want two numbers whose product is negative 2, but the sum is 1. 2 and negative 1. 2 times negative 1, negative 2. 2 plus negative 1, 2 minus 1, same thing, is 1. So we get this, as you can see. That's what we get. Okay, that's fun. Good. Now, so once we have these factored, as you can see, we cancel any common factors, and as you can see, we have x minus 1 is a common factor. So we cancel it, and we get this. Awesome. Okay. Are there any questions about that?